Hello. I was going to say thank you for joining us for the demo today, but I thought there was going to be multiple ones running at the same time, so you don't actually have an option. So thank you for still staying in your seats while we go through this. Today we're going to go through how Genomics England is using Dremio and data lakehouse to support the National Genomic Research Library. There we go. So I'm Johnny Blanksby. I'm a product manager at Genomics England for data infrastructure. This was me when I had a bit more hair. And this is my colleague Tina.
Yeah, I'm Tina, and I'm a data engineer that's implementing data products for researchers at Genomics England. I'm not the only one, but part of a team.
So on our agenda today, hopefully this is going to go to the next slide.
Should I?
There we go. Okay, thank you for that. So on our agenda today, we're going to run through who we are as an organization, why we moved to, maybe why we made the transition to Dremio and Data Lakehouse, some of the challenges that this is helping us to solve, and what our future plans are for the product. So who are Genomics England? Well, we're a healthcare data company that supports the NHS. So patients with rare diseases and cancer can have their genome sequenced and their and their health records collated to a single location, which is the research environment or the National Genomics Research Library. Also, we work as part of the generation study, so anyone that's had children recently and is in the right sort of trust for that, you might have heard of the generation study, where we are sequencing newborn children where parents have consented and looking for rare genetic conditions that can be treated in the early stages if caught. So we make this available to clinicians and researchers to help discover new therapies and diagnostics in our research environment. To store and analyze this data, we had to develop a research environment, or the NGRL. This contains over 200,000 sequenced genomes, 60,000 pathology images, and a lot of other associated data. The total amount is around 80 petabytes of data. The vast majority of that is unstructured and genomic. We have significantly less structured data. It's one of the most comprehensive genomically linked data sets, healthcare data sets in the world, and we have two major sources of data. So the first is the genomic data, and this is a patient's genetic makeup or their DNA sequence, and the second is clinical data, and these can be people's individual healthcare records, so any interaction with the healthcare system across the lifetime of a patient. In our demo today, we're mainly going to be focusing on the clinical data, which we've stored in our data lakehouse and are querying with Dremio. So our data is constantly changing. Not only do we have new participants joining the NGRL, but existing participants' data is being updated with new information, new conditions, and new medical events. Probably not as much new data as Merlin are experiencing, but still quite a range of new data types. Also, we're always looking for opportunities to enrich the NGRL, so that might be getting data from new data sources, new data sets, and trying to build up we've always got a backlog of new data that we're trying to introduce to help with research. We also need to manage changes in participant consent, so removing access to the data of participants who have withdrawn from programs. And as our data is being used by researchers for publications and clinical diagnoses, it's also crucial that we can guarantee that the data a user is working with can be fixed to a point in time so they can refer back to it in the future, sometimes for up to 20 years later. Come on. There we go. And so it's for these reasons that we moved to the data lakehouse solution utilizing iceberg tables and Dremio as our query layer on top of this. Instead of releasing new tables or appending new information to existing ones, we could manage change through snapshots. So whenever changes occurred, a new snapshot could be added to the iceberg tables and schema enforcement became much easier. And this allowed us to present our data in a more homogeneous way in a unified data schema. Our auditing and understanding the impact of historical data changes also became significantly more manageable. Through Dremio, we were also able to create virtual data sets and curated workspaces rather than just providing the underlying tables. And this meant that we could quickly implement small changes to tables, but importantly provide different views of the same data without building complex ETL pipelines or paying for any additional storage. We can see some of these different use cases here. So with the curated workspaces, we're able to promote specific tables that are more relevant to different types of research and sort of provide a more distinct view of our data. You can see cancer, COVID, and rare disease being some of our main areas of research. Virtual data sets also mean that when we implement a change to the real underlying data set, it propagates to all subsequent views, automatically making updates a straightforward task. Now I'm going to go through a few particular challenges that we face in the NGRL and how we're solving them with Dremio. So among the NGRL's challenges are the consolidation of different programs. We refer to, NGRL, National Genomic Research Library, if that link hadn't been made clearly before. It's not just one program of different participants. It's been created by multiple programs over the last 10 years being joined together, some of which being tens of thousands of participants with cancer or rare diseases, sometimes just 100 participants or so that have come for a partnership that have a very specific condition. We even had a large quantity of participants join the NGRL during the pandemic who were impacted differently from the COVID-19 virus. So because of this range of different routes of participants making it to the NGRL, the 10-year variance between when they were recruited and medical data that can span over the lifetime of a participant, there's quite a large range of different data endpoints on very similar but semantically different data that has changed because of changes in data standards or the source of where it's coming from. Previously, we managed and released these programs separately to each other, but this was reducing researchers' ability to run larger studies and could mean that participants that were part of smaller studies were being overlooked. With snapshots, we had a much more reliable way of syncing our data and releasing it in the same iceberg table, and this meant that the data was presented together, but we still had a large range of different users with different specialties, different nationalities who are used to different models and different standards. We needed a way to provide our data catalog information, so business terms and detailed descriptions of columns and data quality results in a user-friendly way. Added to this challenge is that the research environment is only available via virtual machines, and so many tools such as basic internet access are restricted. And this was where the wiki in Dremio became particularly helpful, and I will hand over to Tina for how we implemented this.
Yeah, so as Johnny has mentioned, we have like a vast range of like different data sources, different types of like medical data, and it's quite technical in the sense that like if someone has been recruited on like a COVID program, there are a lot of things that are not like intuitive. Like if you see a column, you might not understand what the medical doctor was trying to say. And even when you read like the values in the column, it's not like male, female, where you know that's gender. It could be something that is very specific to the context in which it's collected. So we're combining all those programs and all those data sources into a unified data layer, which adds additional complexity for the person using the data, because they don't just need to understand the context of one program. They need to understand the context of the different programs and how things change over time. So one way we've solved that is we've deployed a business data catalog using Amazon Data Zone. And this, and this allows us to like centralize all the metadata about the assets from Glue, because you can automatically integrate Data Zone with Glue as a and pull in the metadata about the S3 objects, but also pull in the automated data quality evaluation rule sets. And the other benefit of Data Zone is you can also enrich the basic metadata with custom forms. So you can have subject matter experts come in and provide additional tags or classifications about the assets. So once we have everything in Data Zone and it's been approved and published, then we're able to pull it into Dremio using like Python workflows and querying the Data Zone API. And that allows us to only extract the select information that is appropriate for a view, and do that, like extract what's relevant for different views or different spaces or folders and present it in a user-friendly way for the user. So on the next slide, it's just briefly to show what this would look like in Data Zone. So you can see we have a lot more tabs. Like obviously we have the table description and the column descriptions, and these data quality rules are automated by Glue and populated directly into data zone, but for each use case, we might only want to pull. So for example, like some views may not have every column and may not have like all the information in the table. So this allows us to have a centralized place. And then on the next slide, when we pull that into Dremio, it looks a bit more user-friendly, and we can split out like the data quality rule sets into specific columns. So our users don't need to do like select count all and divide by count this to know that, you know, a table is 100% complete. But also like this is co-located with the view and within our research environment that does not always have access to the internet. So people don't need to go and Google like what does, you know, media and Astino sampling, whatever means. They can just have it here co-located with the asset within our research environment, and this makes it much easier for people to just crack on with their analysis. Yeah, so back to you, Jen.
And onto our second challenge, which for some reason the title has disappeared at the top, but it's on authorization and authentication. So because of the industry we are in, our users often need to push their data into specific tools or applications that support them in their bioinformatic workflows and genomic research. This means that it's crucial for our query layer to be able to integrate with other third-party tools, and the authorization is done on an individual and project level so that access is appropriately managed. It's really important to us that we're able to integrate with these other tools without having to have multiple logins occurring, and that we're not having to rely on having siloed authorization or authentication being managed in other products or tools, or that we're relying on third parties to deploy or apply our own rules. And so I will again hand over to Tina on our implementation.
Yeah, so as Johnny mentioned, we're dealing with patient data and we're quite risk averse, so everything has to be very tightly secured, including how people log into an application. We can't just expose every single application and endpoint to every user. So we have two workflows currently for authenticating into Dremio. So the first one is the more straightforward one that people are accustomed to, where when you get onboarded into an organization, as maybe if you're using like Okta or a certain identity provider, you're added to the application, you're assigned some groups, and then you can authenticate to an application like Dremio that way. So you basically go to like, you know, your Okta application and select Dremio and authenticate that way. We cannot make this available to external people because, again, we're quite risk averse. We don't want everybody using the same Okta tenant and risking access to things that they should not have access to. So what Dremio has allowed us to do is to abstract authentication away from external users by using like a third-party application. So we'll have like a virtual desktop or some other application sitting on top of Dremio where people log in, and then that application is able to authenticate behind the scenes to Okta, grab a token and exchange it with Dremio so that the person can run queries without necessarily exposing our endpoints and risking having people, you know, access our Okta tenants and things like that. So this allows us to support these different use cases and maintain the security standards that we've promised patients.
And our final challenge, which again is on access control management. So like I was saying, the NGRL is actually made up of multiple different programs and groups of participants that have agreed to be a part of research. And because of this different range of routes into the NGRL, not all research projects can access all different types of data. So it might be that because of the program that's come in, only certain types of research are able to be performed on the data. Or if the data has come in as part of a partnership, the participant data might be under an embargo for a period of time. Or it may simply be that the type of consent that the participant has agreed to means that it restricts certain projects' access. We have around 400 active projects at the moment, and because of these different rules around what participant data can be used for what project, we can end up with each of these projects having a unique list of the 280,000 participants that we have. And this is challenging for us because we want to present all of these different routes of data together in homogeneous tables. Previously, we were having to manage this by splitting participants into different tables and managing access on a table level. This was not a great user experience. Users were having to do lots of different joins. And again, participants that were part of smaller studies that were separated into just a couple of hundred were often being overlooked as part of publications. So we're solving this by utilizing data filters, presenting all of that data in homogeneous tables, but then controlling the return results so that they're appropriate to both the user and the project that they're working on. There we go.
Yeah, so on the authorization piece, we obviously do a lot of work to figure out who should have access to what is the criteria for that access, and then we group everyone into like the appropriate octa groups. And I think the interesting part about this for us is that once we've done all our like user group mapping and lake formation grants, the integration with Dremio is quite seamless, and the user doesn't need to like understand what's going on behind the scenes. All they do is log in and make a query in step 1, and then Dremio will take care of interacting with our lake formation access controls, querying it at runtime to say, does this person have access to this table or this row, and providing back to the user the result that matches the access grant that we've implemented. So the integration with Dremio on this is quite seamless, both from configuring the data sources. You literally just select, this is a lake formation enforced data source, and then that's taken care of. And also like the user doesn't see any like latency in making a query because Dremio is trying to figure out if they have permission. For the user experience, they'll just make a query and either get access denied or a query result, and yeah, it doesn't add any latency or affect the user experience. But again, it allows us to centralize our access controls within AWS Cloud, because again, we're quite risk averse and we need to be in control of our governance solution. We can't just use another application to do it. So yeah, so it's the main benefit here has been the ease of integration and user experience remaining the same, both with like lake formation managed assets or those that are not managed. Yeah.
And so our future plans with the product, there's 3 areas that we're particularly interested in. The first is better leveraging the user metrics that we can get automatically out of Dremio. So we're particularly interested in getting a better understanding of which of our data assets are most integral, I guess. Interrogated was the word. That was what I was trying to find. Most interrogated, so that we can pinpoint our sort of data quality improvements to those tables. But alongside that, we're interested in users that are running sort of more complex compute queries and making sure that we're managing those queues effectively so that those more complex queries aren't impacting other simple, more structured tables. AI-generated queries. So we have a large range of different technical experience for our users, a decent proportion of which have almost no SQL experience whatsoever. So we're particularly interested in some of the talks from earlier today, but on AI support in generating SQL queries to help with our no-code users, and ultimately reducing the time it takes for users to understand the data in the NGRL and get some results out of it. And then a project that we're particularly interested in is expanding our data beyond just clinical data in Dremio. So we're doing some work at the moment in partnership with Dremio at putting our variant store data into a sort of queryable data lakehouse. What a variant store is it's like a consolidated version of your genetic makeup that's really looking at where your specific DNA sequence differs from the human reference genome. And it's almost like like I said, it's more consolidated in a more structured format for being able to run queries. if we're able to put that data together with clinical data, it would greatly reduce the number of different applications and tools that users would have to learn to interact with, and again, speed up the time it takes to get results and exports out. So that was all on our talk today. Just before, I just want to give a really big thank you to the Dremio support team, David and Ash and Carsten, who've been helping us with a lot of these different challenges and the variant store work that we're doing at the moment. It's made a significant difference having them on board to give us help with this, and definitely expedited the process. And yeah, that's all from us. So thank you for listening.